Hi everybody, I wanted to work session 17, question 11. So the question states, is each compound more soluble in acidic solution or in pure water? And explain. And so when we think of acidic solution, you want to think of having an abundance of hydronium ions in solution. And the question you should ask yourself if you have this type of problem is, will the anion of my salt that I'm looking at react with the hydronium ions? And then we'll discuss, well, if it does, like how does that impact its solubility? And so when we look at the anion of this mercury bromide, we have bromide here, and that if it were to react with the hydronium ions, it would make hydrobromic acid, and we've learned that hydrobromic acid is a what type of acid? It is a strong acid, which means it dissociates completely into ions, right? And so even if there's hydronium ions in solution, they're not going to want to react with the bromide to make HBr, right? Because it's such a strong acid. So there's not a huge affinity for that bromide to do that. And so therefore we would just say that this compound here would be soluble in pure water, that adding acid to it is not going to make a huge difference in its solubility. But let's look at magnesium hydroxide. It's a little bit of a different story here. So magnesium hydroxide, if we put this to water, would form magnesium ions and hydroxide anions. And if we add the hydronium ion solution, you think, will that react with my anion? The anion here is hydroxide, and yes, it does. Right? If we react hydroxide and the hydronium ion, we get what? We get water. Right? And so as we add more hydronium ions in solution, the hydroxide ions are reacting with them. It's decreasing the concentration. So based on Le Chatelier's principle, will the equilibrium for magnesium hydroxide shift to the left or shift to the right? It would actually shift to the right. And in doing so, that means in acidic solutions, magnesium hydroxide is more soluble. Once again, because we have an abundance of hydronium ions which react with the hydroxide, thereby decreasing the concentration and shifting the equilibria to the right. So for this one, it's more soluble in acidic solution. Calcium carbonate. So let's look at the next example here. If we were to write the equilibria, the calcium and carbonate is the anion, we ask ourselves, okay, will this carbonate anion react with the hydronium ion here? And yes, it will, right? And so we have the hydronium ion in solution in the presence of carbonate. And I'll just do one proton at a time, or I'll do this here. And so you make carbonic acid. Now, is carbonic acid a strong or a weak acid? It's a weak acid. And so therefore, it will react. So the hydrogen ion will react with carbonate to form carbonic acid. Carbonic acid's a weak acid, so it's not going to dissociate like we saw HBr dissociate earlier, being a strong acid. And so in that case here, more hydronium ions means we decrease the carbonate concentration and shift the equilibria to the right here. Okay, so calcium carbonate would also be more soluble in acidic solution. And then silver iodide. Silver iodide would dissociate into silver and iodide. Once again, we ask ourselves, will iodide react? Well, technically it would react with the hydronium ion. But it would make hydrogen or hydroiodic acid. And in that case, would it actually form? Well, hydroiodic acid is a strong acid. And so it's not going to want, the iodide's not going to want to react with the hydronium ion because it would form hydroiodic acid. We know as a strong acid that wants to dissociate completely. And so you would say for this one, be soluble in pure water. So in summary, when you're asked this sort of question, if it's going to be more soluble in acidic or pure water, you want to remember that acidic solutions have hydronium ions. You want to look at the anion. If the anion is the conjugate base of a strong acid, it's not going to be more soluble in acidic solution. But if the anion is the conjugate base of a weak acid, like in the example of hydroxide or carbonate, then those anions will react with the abundance of hydronium ions to form those weak acids, and that will affect the equilibria, the solubility equilibria of these solids, right? And then we can understand how it impacts it based on Le Chatelier's principle. All right, if you have any questions, let me know.